All right, okay. Good? Okay. Wow, there's a lot of people here. Hi, I'm Chris Nunciato. I'm a developer here in Seattle. This is, as she said, my fifth CascadiaJS. I love this conference. I'm excited to be here. I don't know if I'm super excited to be standing right here right now. Not my comfortable zone, but I am grateful to have the chance to talk to you about something today that I care a lot about. This is my first talk, but it's a talk I've been wanting to give for a long time and couldn't really until now, and you'll sort of see why later. I work at a little company here in Seattle called Pulumi on an open source project also called Pulumi. We make things that let you do stuff with the cloud and such. You'll learn a little bit about Pulumi today, along with some others that are in this space. Yeah, and the talk I want to give is called Programming the Cloud with JavaScript, and it's going to go a little fast because there's a bunch of stuff I want to cover, but it'll go in kind of three parts. The first part will be just a little bit about kind of how I came to care about this subject, about infrastructure and infrastructure as code. Secondly, a little bit about kind of what that is, what it looks like, why it's important, stuff like that. And then a little bit about what you can do with it today. So just to kick things off, a little bit about me. I'm just this guy that makes web apps, pretty much. It's what I do. I actually went to school to make movies, but I spent all my time kind of doodling in the margins of my cinematography class about all the web apps I would make when I got out of film school. And I love all the web stuff, all the CSS and JavaScript and REST and APIs and SQL and OPSI things and so on. I'm definitely a front-end focused developer, bit of a UX nerd, but I kind of love the full stack. Usually the apps I like to make kind of want the full stack. I've been doing this a long time. This is my first website. I think it's old enough to vote now. Classic ASP still runs, by the way. And this is an architecture diagram, my first website. It was just a website. Single server, ran Windows, pushed my files up over FTP, YOLO, straight to prod, and if something went wrong, I would just kind of like edit it in Notepad and hopefully copy it back to my machine when I was done. Times were simpler then. This is my current website. I'm a dad now. I take lots of pictures. I shoot lots of video. But this site is kind of like how I use this site to kind of capture the moments, capture all my little moments. It's kind of like my little art project. And I've been building this thing up and tearing it down probably for a decade now. And it's still not perfect, but mechanically at least, in terms of what I can do with it, I'm pretty happy with it. And this is an architecture diagram, my current website. It looks over-engineered, but it's totally not. I need it to be this way in order to get the workflow that I want, which is to take a picture with my phone or to shoot a long video like a snail crossing the sidewalk. And with a single gesture, upload it to a site that kind of gets driven off of Git commits and is statically generated and all that. And that belongs to me and not like Facebook. If I didn't do it this way, if it didn't work this way, I just would never use it. And I don't think I would have been able to do this if I didn't have some of the tools and techniques that we'll kind of talk about today. All right, so about 5 years or so ago, I realized that if I wanted to kind of really be able to build the kinds of apps that I wanted to make, professionally, but also just creatively, I'd really need to kind of learn how to manage my own infrastructure. I could keep pushing my code to Heroku, and that'd be fine, but I really just kind of wanted to know more about how to kind of manage my own servers and such so I could do it all myself. So I landed at a company also here in Seattle called Chef, and it was at Chef that I learned about this concept of infrastructure as code. Which was a kind of a vague and kind of buzzwordy sound to me at the time, but or term at the time, but really does kind of stand for something pretty specific and kind of at the core of modern software delivery and automation today. And so if by infrastructure we mean this stuff, so like the servers, the storage, and networks, and DNS, and kind of higher level services and such that our apps need in order to survive, then infrastructure as code is just the representation of all of that stuff, or as much as possible, as code, just like this, so that we can manage it, much like we've learned how to manage our software. Well, why would we do this? Well, so the journey kind of starts sometimes a little bit like this. So this is just me kind of clicking around in the lovely DigitalOcean dashboard, creating a virtual machine and a database just to kind of stand up a typical web application maybe. And then I kind of Google around a little bit to figure out how to install some software on it and such, and just doing this whole thing manually, just doing the thing that you do. This totally works. This took me about a half an hour to stand up this application for real. And it wasn't too bad. At the end of it, I had a working thing. But this approach kind of brings with it a few problems. For one, you can't see what's inside. You can't look at the server from the outside and see what's on it, like what's installed, what versions of software we have installed, what versions of our application is installed, and so on. This kind of comes up more often than you might think as something you might like to do. You also can't duplicate it, so it's kind of a unique snowflake. If you had to make another one of those, you'd have to do all that same stuff kind of all over again. Not a huge bummer, but kind of a pain too. You can't scale it out. So if this app that I had made suddenly took off and I needed another like 5 or 10 instances of it, I've got a little bit of work to do now. And anything that needs to be done on one of those instances then has to be done on all 5 or all 10 of them. And even if it's just like bumping a version of software or releasing an app and stuff, that starts to become a bit of a part-time job. And because I'm a person, I'm probably going to mess it up now and then too. And then you can't recover from disaster. So like things go wrong. It's super easy in a dashboard when all this stuff is really virtualized, that for somebody to click the delete button on the wrong thing and just have stuff disappear. If you can't kind of build all that stuff back up again from scratch, you're in for like a really sad time. This is my daughter. She gave me her permission. So infrastructure as code kind of addresses all these problems by taking our hands kind of out of the computers and putting them into our IDEs where we can write code that expresses what we want and let the tools run that code to make it happen. Okay, so what does it look like? So the tools of infrastructure as code kind of fall into 2 categories typically, configuration management and provisioning. So we'll take just a quick look at both. So this is Chef. Chef is a config management tool. This is a Chef recipe that installs an Nginx web server, sets a default document for it, and then starts it up. When I run this recipe with Chef and I point it at a server somewhere, Chef will make it so. It will drive that server to the desired state that I've declared in my Chef recipe. If I run it again just after that, Chef will do nothing because that desired state will have been achieved. Config management tools typically fall into, I screwed this up. I knew I was going to do it. So some other config management tools you might have heard of are Puppet, Ansible, and Salt. So the thing with config management tools is they take a server and they keep it configured over time. So you can run the recipe, install the software, and then kind of manage it over time. So this is Terraform. Terraform is a provisioning tool. Provisioning tools will generally create infrastructure from scratch. So whereas with Chef, we pointed it at a server, with tools like Terraform, we point them at a cloud like AWS and say, go make your stuff. So here, I've just expressed that I want a virtual machine that I can connect to over SSH, and Terraform kind of figures out how to do that. You might use Terraform to spin up some virtual infrastructure and then run something like Chef or Ansible against that infrastructure to make it happen. Some other provisioning tools you might have heard of, in addition to Terraform, AWS CloudFormation, which uses a YAML syntax to specify the resources you want to provision, and Azure Resource Manager if you're using the Azure Cloud. So a couple things these tools kind of all have in common. One is that they're generally declarative. So we, as developers, as writers of the code, we express the what, and then the tools figure out the how. So instead of saying do this and then this and then this, we say I want this, and then the tools kind of go and make that happen. And secondly, they're idempotent, which is kind of a term borrowed from functional programming, which here kind of means given some code as input, we can run that code over and over again and get the same result. So what all this gives us in the end is like infrastructure that is much more reliable and repeatable, replicable, so we can stamp out more and more copies of it, self-documenting, and just generally collaborative, which kind of leads to a lot more happiness and a lot less sadness in general. It takes a little bit of learning, bit of work, but it's super worth it because it lets us ship lots of code really often, really safely, and that's kind of what it's about. And also, it just feels awesome to like write code that makes computers. It's just cool. So I learned all this stuff, right, and I was loving it. I was building full stack apps with my teams, and I was building dad blogs for myself, and I was kind of driving it all with Chef and Terraform, and I was happy. But then I go to these DevOps conferences, and like there were no devs. And I come to conferences like this one, and no one was talking about infrastructure, which was strange to me because this was infrastructure as code. It was supposedly, in our wheelhouse, but we weren't using any of these tools. Why? I've thought about this a lot, and I don't think it's that we don't care about infrastructure. I think we would like to be able to manage this stuff if we could. We just haven't really been shown that we can do it with tools that kind of naturally extend our mental models of the world and kind of fit into our existing workflows. The tools that we've talked about so far are amazing tools, they really are, but they're not really made for developers. They're made for managing that operating environment, and so the abstractions and kind of their abstractability in general just sort of stops there. We as developers tend to cruise at a kind of a much higher level relative to that operating environment. So, if that's my app box up there, like I kind of just want my app to work. I might know that I need Node, maybe to be able to talk to this thing or that thing, but kind of too far below that, I'm in unfamiliar territory. I'm not really sure I want to get involved. If we're going to manage our own infrastructure, we really need the tools and the abstractions to rise up and kind of meet us where we are. Otherwise, we won't use them. I think that's why we haven't. But over the last year or so, year or two really, some interesting things have started to change. One is that some very developer-focused developers from kind of outside of the ops world recognized this problem and went to work to bring modern programming languages like JavaScript to the infrastructure party. Clicker's not working. Another was that cloud providers like AWS, this is an interesting one, kind of started to move beyond these like big, sort of heavyweight constructs like virtual machine and database cluster into these sort of much more lightweight ones like function and event and route, and table and record, things that fit much more naturally into application code. And so it turns out that when you combine the practice and the discipline of infrastructure as code and kind of all the learning that we've done there with the expressive and compositional power of a modern programming language like JavaScript, and these now very lightweight, app-friendly cloud primitives, what you get is something that we haven't really had before. When I said that I couldn't give this talk until now, this is kind of why. So there are two tools out there that I'm aware of now that let us do this now with JavaScript. One is AWS Cloud Development Kit. CDK takes your JavaScript and transpiles it into CloudFormation YAML, which can then be uploaded to AWS and turned into cloud infrastructure. I won't dive too deeply into CDK because I don't have the time. I don't really know it that well, but it's JavaScript, and so it's definitely worth your time to take a look at it. The other one is Pulumi, which I discovered about a year ago, and now I work on myself, and I'll be showing that in a little bit. So to get a sense of how to do all this in JavaScript, we're going to build a little app. This app is going to let us upload pictures and show them on a web page, something that is close to my heart. We'll upload those pictures to an S3 bucket. We'll turn them into ASCII code just for fun, and then stash them in a serverless key value store called DynamoDB, and then build out a little API that just lets us render them in a browser. Okay, so this is going to go fast. I've done it as a video just to sort of show the whole thing. I did it live, but I squashed the time down just so we could see the whole end-to-end thing and see something that wasn't just a trivial example. And also, like, watching me type is seriously terrible. All right, so I'm going to take a drink of coffee. All right, so here we go. I'm going to talk through this now. So I've installed Pulumi with Homebrew already, and I'll just say Pulumi new to just like scaffold out a quick little project. And I'm going to choose the AWS TypeScript template here because those are things I like. And we'll give the project a name of ASCIIgram and just a description, and then a stack. So a stack is like a collection of cloud resources. You can think of a stack generally sort of as an environment. So we've got our dev environment. You might have your test environment, staging environment, so on. We'll look at that again in just a sec. So we'll just pick dev. And then we'll deploy into US West 2. Region of AWS. So Pulumi's kind of doing its thing, it's installing its dependencies and so on, and now that it's ready to go, we'll switch over to VS Code and see what it's made for us. So we've got our project level configuration first. This is the thing we gave a name to and so on. And then we've got our stack configuration file. So in this config file, we can set the things that we care about at the application environment level. So we might have settings that are specific to dev or testing or staging. Config settings, secrets, and things like that can go in here. And then we can reference these in our code. I don't have any to show, but that's where they would go if I did. And then the index.ts file is the file that we're gonna build out. So Pulumi's basically stubbed out a bucket for us here, an S3 bucket that we're gonna build onto. We've pulled in some libraries to let us sort of declare cloud resources. And now I'm just gonna I'll just add a few comments just so that we can see what it is we're gonna build as we go. So the first thing we're gonna do is we're gonna create a DynamoDB table to hold those images. Then we're going to write some code to handle uploads to that S3 bucket. And then we'll make a home page and a JSON API. And then lastly, we'll just export the URL of the website so we have something to browse to. Yeah, so we'll just get started first declaring that table. So we'll just say new aws.dynamodb.table. And so notice as we run through this code, we get that rich developer experience of the code hinting and the syntax highlighting and the squiggles and everything. All this kind of helps you stay on the path of developing a cloud app, without having to constantly refer to documentation and such. It's just a helpful development tool. We're going to key these images with a creation date of just a timestamp. And the read capacity and write capacity are just DynamoDB settings that have to do with throughput and consistency. So that's it. So we've declared a table now. Now we'll go and declare the bucket callback. So we can build right onto the bucket object that was declared on line 14 and just say on object created. And then we'll pass this an async callback. First thing we'll do is just log out the event so we can just see something happen. And if we happen to get an event that has nothing useful on it, we can just bail. And now we'll pull the metadata out of that event so we can start to do something with it. That's going to have information about the bucket and the file that was uploaded and things like that. So we can use the AWS JavaScript SDK here to just connect up to the S3 service. So we'll just say new S3, and then we'll call s3.getObject with that. And so we'll pass the bucket, which is the bucket that we defined up above, and then and a key that is just a path to the image inside of that bucket. And we can pull that right off of the metadata from the event payload. And yeah, so now we'll just askify the image. So we'll just npm install that library. Thank you to the authors of Askify Image for making this demo possible. It's actually a fun little library. And then we'll just pull it into the program, as you do. And so now, on that file object above there, we've got the bytes of the image as a buffer, so we can just pass that to the Askify function to give it some properties to draw itself out. And now we'll just write the thing to the database. And so we'll use again the AWS JavaScript SDK and its DynamoDB document client. And with that, we'll call client.put. I think this is where I have an awkward pause. Yeah, there. Okay, cool. Yeah, client.put, and then we'll pass the table name of the table that we declared up sort of at the top of the program there. And then the item that we'll create is just going to be a two-property object with the creation date, like I mentioned, of just now. And then the item itself will just be the Askified version of the image. Cool. So now we've done that. So I think that's done. That's the end of that. Now we'll just make a home page and an API. So we've got an API for this too. So we'll just say new awsx.apigateway.api, and we'll just pass this a couple of routes. The first route will just be a path of / to the home page. We'll make that in a sec. And then we'll create a route to /images, which will respond to GET requests and return our images for us. So we'll just pass an event handler here with an async function in line. And with this, we're going to connect up to the database and fetch the images. So we'll just say new aws.dynamodb.client again, like we did above. And with this one, we'll say client.scan, which pulls all the images out. And we'll just sort of specify the table again, which table we want to pull images from. And the projection expression is just the fields that we want back on the result set. That's it. So that's, oh no, actually we're going to return a 200 OK, and then with the stuff that we care about. The list of images. And that's basically the program. So, so now we'll export the URL of the finished website so that we have something to browse to. All right, so just to like recap what we made here, so we wrote some code to make a table, to declare a DynamoDB table, a bucket. We've got our callback handler that responds when something is uploaded to that bucket. We've turned it into text, written it to the database. We've got our REST API endpoint there. Now we'll just like throw together that web page. And I'll just make a www folder and an index.html file and just paste some code in here that has that web page in it. And all I'm really doing here is just calling fetch on that /images endpoint and just looping through the images in that result set and attaching them to the DOM. All right, so now we'll call, with all that code written, we can call Pulumi up. And so Pulumi is going to like look at that JavaScript program that we've written, figure out what it is that we've declared there, and kind of compute a set of resources that need creating. So we've got our bucket, our table, our API there, and then a handful of other things. See, our inline Lambda function stuff there will all be declared as part of that program, because Pulumi's just realized that that's probably what we want to do. We can encapsulate all that stuff because we're using JavaScript. And so I've said, yes, go ahead and proceed. Now Pulumi is kind of running out and creating all of those cloud resources for me. This takes a couple minutes in practice. And then so now that this is done, we can see the exported URL there. That's our running service. We can also browse into the Pulumi console. This is kind of handy because you can see over time, your deployments over time, and on a stack specific basis, you can look at the resources that have been deployed into that stack, and you can link off to them. You can see them as a graph. This is just a helpful way to see kind of what you've got. Yeah, kind of like a, oh, and then the config values and stuff for every stack. It's just handy. All right, so now we'll open up another tab, and we'll call Pulumi logs-f to follow the logs of this application. The Pulumi app kind of wired this up for us, thinking that we would probably want logs. And now I'll upload a thing to the bucket. So I can say stack output to reference that bucket name that was dynamically generated for us. And when we upload that, remember we had a console log statement in the program. So off to the right there, we'll see that event get logged. And now that that's there, that means that we have the image in the database. So we should be able to just browse to that URL that we created there and see what we will hopefully have enough contrast to that. Yeah, you can kind of see it. All right, there it is. Yeah, so there's a little image. That's it. So what did we do there? Yay. So what did we do? We built an event-driven serverless application that blends cloud resources and application code into a single cohesive JavaScript program. That's the app. It's like a cloud resident app, so to speak. We could go further, like we could factor this out into modules, we could push it up to NPM. We can work at higher and higher levels of abstraction now because we're just working with JavaScript. Pretty cool. And we also programmed the architecture diagram. We literally said we said new bucket, new table, new API, and there it was. We could even say new EKS cluster if you were courageous. Yeah, pretty cool. So I'd love to tell you that it's going to be like all sunshine and rainbows and plastic monkeys happily running off into the plastic monkey sunset. But and it totally does feel like this sometimes to write this code and run this stuff. But honestly, if it's new to you, especially, it's also going to feel like this sometimes. This is new stuff. These API surfaces, particularly for the cloud providers, are really vast. The SDKs are constantly evolving, and you're going to hit rough edges there now and then, but as you would with anything new. But this is the stuff that I, as a JavaScript developer, have always wanted to exist, and now it does. And that's why I came here today, to just show that to you, and also, yeah, to encourage you to give it a shot. Thanks very much.